Hello, if you're watching this video, it means that you followed my Reddit post and you clicked on the link and now you're here, and it means that you might want to learn some calculus. So just to reiterate, I am a graduate student at UC Berkeley. I study math and I really want to help a few of you study calculus and get better at it. So no matter if you're taking a formal class or you want to self-study for the class, I want to teach you Calculus 1. If you've already taken Calculus 1 and you want to do Calculus 2, I will probably do something in the future about it, but for now, I just want to do Calculus 1, following Stewart's book or literally anybody's book. You don't need to buy a book for this, you don't need to do anything but actually do the work. I will type out the problems, I will do the syllabus, I will post some homeworks and some quizzes just so you can self-assess. I do want this opportunity to be exclusive to students who actually want to do the work because of a previous experience. It's very easy for people to forget to do this, which is why we'll do the following. I will present very shortly to you a method for finding the minima and the maxima of quadratic functions. We'll solve a sample problem, and after we solve the sample problem, then I will give you a challenge problem. If you want to be in the course, DM me back on Reddit with answering the questions that I posted in the Reddit post and the challenge problem. Okay, so let's get right into it. So we have an example problem on the screen right now. So we have a farmer, they want to make a sheep pen and they want to put a fence around it, but they only have 300 feet of fence. Not to worry though, because they can use the side of their barn as one of the walls of the pen. So the question is, what is the maximum possible area of the pen if we want to keep it rectangular? So before we can answer this question, we will learn how to minimize and maximize quadratic functions. And by the way, the reason this YouTube video even exists, the reason I'm putting myself on screen, is because a huge portion of this class, my only portion in which I'll be able to interact with you directly and not over text, will happen on Twitch on a new channel called KD Math, just like it says right here. Which is where we'll go on Sunday for about 2 hours. I'll just answer your questions live. So that's the non-exclusive part of the class. But if you want to be in the Discord, if you want to be on the Piazza, if you want to have daily interactions with me, if you want to have the quizzes, then you do need to do this part. You do need to do the work. So let's get into the question. So the question is, what do we do when we have to work with a quadratic function and we want to minimize or maximize it? So let's start with our normal, usual quadratic function, ax squared plus bx plus c. So the question is, does this have a minimum or a maximum? Now, in the context of this class, we will learn how to do this the rigorous way using derivatives, but you can already answer some of these questions, like the farmer question, using your knowledge of quadratic functions, using your knowledge of the, say, the roots of the quadratic function. So for now, I'm just going to assume that my leading coefficient a is positive. So if a is positive, then we can say, well, this equals to a, and let's call this f of x. Right, I'm doing this single take, by the way, like there's not going to be re-recordings of this. So let's factor out the a, and we get ax squared plus b over a times x plus c over a. And this is still our f of x. Right, okay. I'll just give you a moment to catch up and to see what I did. I just factored out the a. And now we're going to do something which we call completing the square. And if you've been paying attention in your mathematics class, this is how you get the quadratic formula. This is how you get the roots of f of x. So let's do a times x squared. Now, we would usually want to have 2 times something times x here, and that something squared again here. So, well, let's factor out a 2. And then we have b over 2a. And then times x. So all we did here was just factor out the 2 and then introduce an artificial 2 in the denominator. And then we add our CA. Okay, this is what we have so far. And now we want to add and subtract the square of this term. so that we can talk about completing the square. So this would be b over 2a squared, but we didn't have that in the beginning, so we have to subtract it as well. Negative b over 2a squared. And this is still our f of x. Okay, so now let's identify the terms. Let me just shift the board a bit to the left. Okay. Let's identify the terms here. We have x squared, 2 times b over 2a times x, and b over 2a squared. Okay, so let's group these three terms. And we leave this term separate, the c over a minus b over 2a squared. We have f of x equals to a times x plus b over 2a squared. Again, 1, 2, 3. These three terms come from here. Plus c over a minus b over 2a squared. And this is still f of x. Okay. So now I want to appeal to you and say, well, the square is always positive, a is positive, so f of x is always going to be greater or equal to a times c over a minus b over 2a squared. Right? And equality, equality has only one L. Maybe. I can usually misspell things. Equality only if one. Well, only if x equals to negative b over 2a. Right? So if a is positive, f of x, our quadratic function, has a minimum. And that minimum can only be reached when x equals to negative b over 2a. And this negative b over 2a we usually call the vertex of the parabola. And hopefully the word parabola is something you've heard before. Again, I'm assuming that the people who are interested in this class are at least aware of how pre-calculus works. Okay. So let's turn over a new leaf. What happens when a is negative? So if a is negative, well, then we still have our function from before, and it factors exactly the same way. A times x plus b over 2a squared plus c over a minus b over 2a squared. Right, that part hasn't changed. What has changed, however, is the fact that when we multiply something by a negative number, we can no longer say that it's greater or equal to than something. We can now say that it's less or equal to than something. And let's write this out carefully. We would get that f of x is less or equal to than a times c over a minus b over 2a squared. And equality is reached if and only if x equals to negative b over 2a, which is exactly the same number as before, except now our a is negative. So if a is positive, if a is greater than 0, minimum at x equals to negative b over 2a at the vertex of the parabola, and if a is greater than, or if a is less than 0, then maximum at x equals to negative b over 2a. You might notice that I'm not writing down what exactly these minima and maxima are. I'm just writing down when they occur, because in practice it's much easier to just compute what the maximum is or what the minimum is by just plugging in the value at which it would be attained. Okay. If you need to pause, just pause the video. I'll just move on. Okay, so now let's get back to our farmer problem and see how we can find an application of this principle. So our farmer, we have to read this carefully. but we want a rectangle of sides A and B. And our farmer has to make 2A plus B equal to 300. So the question is, what is the maximum value of AB? Right? And A can be one of the sides. A is the side that doesn't lie along the barn. And B is the opposite side to the barn. And we're asking, what is this maximum value? Does it exist? Well, let's check it out. Let's say that we have 300. So what do we do here? We say B equals to 300 minus 2A, and AB equals to 300 minus 2A times A. Now this is nice because we can open the parentheses and we get 300A minus 2 times A squared. And if we're very industrious, we can rewrite this as negative 2A squared plus 300A. And now this is a quadratic function. And this is a quadratic function of which we know exactly where the maximum occurs. Why do we know there's a maximum? Because the leading coefficient is negative. So we know there's a maximum at B over 2A with a negative sign in front of it, which is negative 300 over negative 4, which is 75. Now there's a technical point here, which is that 75 actually works for us. Like 75 times 2 gives us a B of 150. We don't get a negative B. This will usually be the case in these problems. So A is this. So this A is not the same as this A, right? This is from the quadratic formula. So A equals to 75 works for us. And then B equals to 150 also works for us. And the answer is 75 times 300, which is 22500. Okay, so this is the practice problem. Now I want you to take what you learned. Let me just switch my problems. Technical difficulties here, if you will excuse me. Okay, let's take our practice problem out of the way and let's put the challenge problem up on the board. And the challenge problem is the following. We have the same farmer, and they still want to make a fence, but now they don't have the luxury of having that barn serve as another side of their pen. So the question is, if they now have 500 feet of fence, what is the biggest area they can enclose? If you want to be a part of this course, if you want to have my attention on Discord and learn from me every day, and have me help you learn every day, I will do this absolutely for free. You just need to DM me on Reddit and tell me about yourself, and then tell me the solution of this problem according to you. The deadline is the end of President's Day. I realize it's a long weekend for a lot of you. So let's just say the end of Monday is when I will be checking my inbox and distributing the Discord links and posting the syllabus and the first week of material that I want you to look at. There is a lot of self-studying in this class. I will not be lecturing you, but I will be available to you if you have any questions as you're reading the book, and as any book, and as you are trying to solve problems. So thank you very much for tuning in. This is a 15-minute video at this point. I hope you learned something. If you just skip to the end to see what the challenge problem is, then congratulations. Here's the challenge problem. Solve it, get back to me on Reddit, and then we'll proceed from there. Cheers.